Okay, so very quick introduction. This is from your lecture questions, your comprehensive notes. Every day, in every part of your life, there's always a time where we need to okay, faster sit down. There's always a time where you need to count things. Okay? There's also a time when you need to count it. It could be your CCA, you count the number of players. There's always a time where a solution is presented, a problem is presented to you, and you have an so-called a number of solutions that you need to count. Okay? So there's a lot of, for example, maybe the question I want to pose to you is this: how do I leave school early today? How do I leave school early? So number one, you can say you fall sick, take blue slip. Number two, you go and take something not on head, then you go to ambulance. Touch you. Okay, number three, example, new family emergency. So there's always a number of ways you need to count. Shh, quiet. People on this side. Okay, there's always a situation where you need to count. You count the number of solutions. Okay. Okay, for example, in the question, number of ways to divide a group of 13 people into 3 groups of 8 people. 3 groups, it's not 3 equal groups, 3 groups of 8 people, 4 people, and 2 people. Okay? Okay? So 3, 8 plus 4, 13 total. To occupy a van, a car, and a 2. So we'll be looking at questions like this. Alright? Okay, so the under this topic, if you go on and you study, maybe you study major in math in your college or university, this is actually under a topic called combinatorics. Okay, combinatorics. Okay, so these are principles of counting, permutations, combinations is under a topic. Okay. First one, addition principle. Okay, so if I want to perform a particular task at this point in time, I want to perform a particular task. I have R choices. I have a number of choices. Okay, to perform this task. Okay, and the key thing is that the choices cannot happen at the same time. The choices cannot happen at the same time. Okay? So, example, I ask you to go to the toilet. Okay, maybe at TC block you go to the toilet. Then you say, hey, no teacher around. You can either choose to use the student or the staff toilet, right? But you cannot go to both at the same time, right? You cannot go to both at the same time, right? Okay, so the choices cannot happen at the same time. Okay? It cannot happen at the same time. Alright? So the number, but how many ways can you go to the toilet? You go to the student one or you go to the staff one, right? I mean, provided if the student one is full, or student and staff one. You don't go to the girls' toilet if you're a boy, okay? Yeah, so there are 2 choices and it cannot happen at the same time, okay? So, number of ways of performing the particular task is equal to the sum of the ways for your choices. So, the number of choices, the sum of the choices are equal to the number of solutions, okay? So, this is the addition principle. This is the addition principle, right? Key thing is the choices cannot occur at the same time. Okay, first question, okay, I know the solution is there, just hear me out, just stay patient with me. Okay, I want to go to town A to town B. Okay, one stage, single stage, I want to go by road A and C. By road, right, I can have 3 ways. Okay, it could be that I take bus, maybe I can take car, I can take maybe a motorbike. Okay, 2 ways by air. What are the ways? Maybe helicopter. Maybe by plane, correct? So maybe can be helicopter also, right? Maybe you happen to know Song Joong Ki, then he come okay. It can be by ship. Okay, so total, but can you take 2 at the same time? No, right? At the same time. If you're not talking about changing bus or what, but at the same time you cannot take both. So every total, the number of ways is just 3 plus 2 plus 1. So very easy. The number of ways is just 3 plus 2 plus 1. The choices cannot occur at the same time. It's a single stage. The choices cannot occur at the same time. Alright? So this is the addition principle. Simple? Simple, right? It's so easy until what am I teaching you? Nothing. Okay, it's just a very common sense, logical. Okay, common sense. Okay, so quick one. Let's look at this. Okay, I think this one is left blank, right? So maybe just 30 seconds, help me to fill up. Simple, not like those PSLE kind of question. Help me count. So, Find the number of squares contained in the following 3 times 3. Okay, so very quickly you can see you can have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is just counting, so you have 9. Okay? 1, 2, 3, 4. Okay? 2 times 2, we can have 4. Last one, the big square. Okay? So you can have 1. Shh. Why someone's talking today? Okay, stay with me, stay with me. Okay, I want to push a bit so can end your earlier, so you can go for your GP test. Okay, I know your GP test, so all the best, all the best. Okay. 9 plus 4 plus 1, total is 14. Easy, right? So this is just an addition principle. Key thing to note, the choices cannot occur at the same time. Okay, they cannot occur at the same time. Alright? Next one. Okay, multiplication principle. Okay, multiplication principle. Okay, if a task can be performed in m ways. Okay, I know your morale is high today. Good. Keep it up. Okay, but keep your morale high quietly. Okay, resist the urge to talk to your friend. Okay. Then following this, a second task can be performed in n ways. N ways. One is m ways. Second task performed in n ways. So there are 2 stages. Okay. Then the number of ways of performing a task in succession is m times n. Okay. Right. So let me go to the first example. Okay. This one, okay, there are usually 2 or more stages. The first stage, okay, in how many ways can 2 pupils of different gender be selected from a group of 4 boys and 3 girls? Okay, I know that you already have the answer. Okay, so I'm just going to go through the answer with you very quickly. 2 boys, right? 2 pupils of different gender. What's the choice? 1 boy, 1 girl, right? Okay, right? Okay, assuming the gender is clear, I mean, no, don't think otherwise, okay? The gender is clear, 1 boy, 1 girl. Okay? We choose the boy first, is it okay? No, okay, so we choose the girl first. Okay, no, we choose the girl. Okay. So 3, girl 1, okay, sorry. Girl 1, girl 2, girl 3. Okay, any other choice? Only 3 choices, right? We choose the girl, after that we choose the boy. Okay? So assuming I choose girl, now I can choose. Okay, so can you see how this is stage 1, so this is stage 1, this is stage 2. Stage 1, I can choose a girl in 3 ways. Stage 2, I can choose a boy in 4 ways. Okay? And you can see that the total number of possibilities, right? How many are there? Total of 3 times 4. Okay, just 3 times 4. 3 times 4. Why 3 times 4? Very simple, you can see 1, this is 1 way, this is 2 ways, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 3 times 4. Okay, so let's say I don't want to choose a girl first. If I choose a boy first, will the result come out to be the same? Yes, doesn't matter, right? Boy or girl or boy, it doesn't matter, right? Okay, you can have a son, then daughter, and daughter and son, doesn't matter. Okay, so you can see, okay, this is what we call an outcome. This is what we call an outcome diagram or tree diagram. Okay, please do not confuse this with the probability tree. Okay, the one that you learn in secondary 2 or 3, secondary 3, I think you learn probability, right? Okay, those tree diagram you did, those set 3E math are 1/3, 1/3. Okay, that's not the same as this. This is what I call an outcome diagram. Okay? I don't mind, just minimize your talking here, okay? I need you to listen, okay? This is just a tree diagram, alright? So number of ways is 12. Okay with this? Simple? Okay, Next one. Okay, again, now we look at badminton match. Okay, could be your own team. Okay, could be you are in a badminton CCA. You have 4 men, you have 3 women. You need to choose. You need to choose a doubles, mixed doubles, Okay, you choose a mixed doubles. Okay, some of you don't understand. You ask me what's the definition of mixed. Mixed means 1 boy, 1 girl. Okay, or 1 man, 1 woman. Okay, please don't think otherwise. Okay, 1 man, 1 woman, 1 man, 1 woman. Okay, so how many pairs are possible? Same thing. We are choosing 1 boy, 1 man, and 1 woman. Does it matter if you choose a woman first? No, right? Because they are independent. Okay? So with that, you can see I choose the guys first. 4 choices. 1, 2, 3, 4. Shh. Liu, keep quiet. Stop smiling. Okay, then after that, I choose the woman. And I have 3 choices. So there are a total of, again, 4 times 3. Total of 12 possibilities. Okay? Can children? Easy, huh? Easy? Easy? Can? Can, I would like to teach well. But to teach well, I need to catch your attention first. So I need to do whatever it takes to catch your attention. Okay. Part 2. Okay, so we are done with addition and multiplication principle. Okay, let's look at part 2. Okay. How do we find the number of permutations of R objects in a row from n distinct objects? Okay, the key word is n distinct objects. Okay, distinct meaning they are different. Distinct means if me and you are distinct, we are different. Different. Okay, why the keyword distinct is important? Because later there will be identical objects. Okay, and you need to study the case where it's identical. Okay, from n objects which some are identical, as well as studying the case where how do we find permutations provided some restriction. For example, I want to how many ways can I arrange such that the first one must be a boy, or the first one must be a girl, or the first one must be from RFM, the first one must be from badminton. Okay, so how many ways can I arrange these students? Okay, so there are also finding the number of permutations refers to arrangement. Okay, arrangement where the order of arrangement matters. Okay. Okay, so a permutation, this is from your lecture question, okay, from your comprehensive note, is an ordered arrangement of objects. Okay, in your permutation, the order matters. The order matters means, if I were to consider this arrangement and this arrangement, are they the same? No, Okay, so you can see I just take 3 cones, I arrange 1, 2, 3, 4, 5, 6, right? How many arrangements can I get? 6, right? Okay, 6, Okay, so in your permutation, the order matters. Okay, the 3-letter arrangement, you can see that I get, if I permute 3, what do I get? I get 6, right? I get 6. Right? So you say, hey, how to get this number 6? Quite interesting. Okay, so how do we approach this idea of permutation? Okay, for example, in this case, you can see, hey, if I were to take 3 cones, alright, teacher asked me, how can these 3 cones, how can I arrange them? Can see, how can I arrange them separately, in different arrangement? There are a total of 6 ways. Can you see there are a total of 6 ways? There are a total of 6 ways, right? How do we understand this idea of permutation? By what we call a slotting method. Okay, we're going to use a slotting method. Okay, so we are going to understand this by using the slotting method. Okay, so suppose given n distinct objects, maybe I give you 5. 1, 2, 3. Suppose I got 5 slots. 5 slots. Okay. Okay, I got 5 slots. Okay, I go to the first slot. Okay, suppose I want to arrange 5 objects, right? Okay, I go to the first slot. I have 5 of them. 5 colored. 1, 5. I have 5 of them, right? How many ways can I put the one band over this? 5, right? So total got. So let's take one. Any one I choose. Which one you all like? Green. Okay. So I choose what green. Okay. I go to the second cone. How many ways can I put a band over? 4. Okay. Just take any one. Then 3. Then left with 2, right? 2. Then after that 1. Then So you can see the number of ways is 5 ways times 4 times 3 times 2 times 1. Okay, very good, very good. Okay, so you can see, right? That's how I permute 5. That's how I permute 5 objects. Okay. So 5 permute 5. You can also see your calculator. Okay, so this is the same as 5 permute 5. Okay. Or I can say that I use the slotting method. Okay, we call this the slotting method. Okay, to permute n distinct objects. Okay, I stress on the word distinct. Okay, you notice, right? All of them are different. Okay, but if I go and put 2, then answer is different. Answer is different. Okay, so wait first. Okay. Okay, so answer is different. Okay, so the number of ways to fill the first slot, 5 ways followed by 4 times 3 times 2 times 1. Okay, then it's actually very nice because 5 times 4 times 3 times 2 times 1 is actually equals to 5 factorial, right? You also remember this? Factorial. This one is not n, then you shout very loud. N! No, it's actually factorial. Yeah. So you need to. Yeah. Okay. A bit lame. Sorry. Okay, but it's your laugh. So catch your attention. Okay, so it's just n factorial. Okay. So it means n times n minus 1 times n minus 2 times 3 times 2 times 1. Okay, So when I arrange 5 distinct objects, number of arrangement is just 5 factorial. And you can see that if I arrange 3 objects, okay, the answer is actually 3 factorial. That's why you got 6. Okay. Okay. Okay, so first one, I want to permute. Okay, I consider that I have 5 men and 5 women. Okay, they sign up for an online dating service. Okay, then how many ways can they be paired up? Right. So again, what we do is it looks very complicated, but actually, all you need to do. Okay, I use this example again now. Okay. Or do I need to get real people? Want to get real people? No need, okay. Imagine these are the women. Don't laugh. Okay. Imagine these are the women. Okay, again. The man walks in from the room. This one is. So the first woman comes. Choose these 5 guys. How many ways? Same thing. Got 5 guys to choose from, right? 5 guys to choose from, right? Okay, so 5. Okay, then this one left with 4 guys. Then 3. Then 2. Then 1. Okay, okay, right? So answer is just 5 factorial. Okay, then some of you will have the question. Okay, so some of you have the question. Then you say, hey, jialat, why if I'm not the first lady and the last lady? Then I have no choice. So let me ask you, for example, maybe this one say you go first, I'm scared, I'm nervous, I'll go toilet. So this one come to the front. Okay, I jump out the posture, okay. Does the order affect the number of outcomes? You can see it's still 5 times 4 times 3 times 2 times 1, right? Also, actually, regardless of how I arrange the woman, it's still 5 factorial. Okay? It's still 5 factorial. So that's the answer, okay? Okay. Okay. So, okay, now, sometimes, we cannot permute so many things. Okay, so the idea that you see now, okay, now I don't use items, I go to theory. We maybe out of the 8, maybe out of the 5, we cannot permute so many. We want to permute maybe R objects. Okay? So maybe out of 5, we only want to choose take maybe 3. You want to take 3. Okay? So example, permutation of R objects taken from n distinct objects in a row. Okay? Suppose I have 3 like that. Now number of women drop. Okay. So I still have 5 guys. 1, 2, 3, 4. I still have 5. But now there are only 3 women. Okay? First one, how many choice? 5, right? So I've got 5. Second one, 4. Third one, 3. Okay, so this is 5 permute 3. Okay? So you can see that if I take 5, right, I so-called 5 objects, okay, but I permute 3, what is the outcome? This is actually like 5 times 4 times 3, am I right? Oh, okay, so you notice when this is n, this is n minus 1, 3, n minus 2, okay, so when it's then the third slot, so-called the third slot, is 2, right? So when it's at the R slot, it's like n minus R minus 1. Can you see R, the relation between this and this? Oh, that's why it's n minus R plus 1. This is from your lecture comprehensive notes again. Okay, so I just put it here for you. When you want to permute R objects taken from n distinct objects, right? For example, 5 permute 3. Okay, this permutation sign you have not seen it. Don't worry, I will introduce to you later. Okay, so for now, I would just like you to be comfortable with the slotting method. That is that if I want to take 5 permute 3, what I'll do is I'll take 5 times 4 times 3. Okay? Can all? So you think like husband choose wife choose husband, husband choose wife. Okay. Always the wife choose husband. Okay. Then next one. Okay, 30 seconds. Just help me to fill up all this. Eight times 7 times 6 times 5 times 4. That will give you your answer. Okay? If you are comfortable with your calculator, some of you may do this, which is 8 permute 5. Okay? 8 permute 5. But for now, I'm not going to talk about this first because I want to talk about later. Okay, I don't want you to start using. I want you to use the slotting method. 8 times 7 times 6 times 5. Okay? This is for permutation of R objects from n distinct items in a row. Okay? R objects from n distinct items in a row. Okay? So I hope you appreciate why is it the teacher tells us are not repeated. Okay, there are n distinct objects. 1, 2, 3, or total 7 distinct items. How many 4-letter codes can we form? With repetitions means what? With repetitions means I can put it and then I use it again, right? Also, it's very easy. Okay, so it means I can use it again. So first slot I put in 7. Second slot I can put in 7 again. Third slot I can put in 7 again. Okay, so you can see that the number of choices is just 7 to the power of 4 because I can reuse the choice. Okay, I can reuse the choice. Okay, without repetitions, okay, then it will be like your normal case. Okay, so it will be the same. First, 1, 2, 3, 4. How many choice for the first slot? 7. How many choice for the second slot? 6. Then 5. Then 4. Okay? Can hold. So, learning point for this question. You must understand what is with repetition, what is without repetition. Okay? With repetition versus without repetition. With repetition means I choose it, I can choose the same one again. Okay, huh? Okay, with that, can you just take 3 minutes, try question 8. Okay, question 8. Can be formed from the numbers 1, 2, 3, 4, 5, 6. If each numbers cannot be used more than once. So this one means what? Can repeat? No, okay, this is actually without repetition. Alright, so number of ways is what? If I have 3-digit number, 1, 2, 3. First one, I can use how many choice? 6, right? 6. Okay. When I reach the second number, second slot, how many choices do I have? 5. Very good. Because I cannot use more than once. Okay. Then 4. So 6 times 5 times 4. Okay. So you can also say 3 slots. You can also say it's 6 permute 3. Okay. Otherwise, okay. But I'm not going to focus on the computation simple yet. Alright? How about the number of required ways? Let's say if the numbers can be repeated. Can be repeated means what? I reach the first slot, how many choices? Slotting method. I reach the second slot, how many methods? 6. Okay, in unison. Third slot, how many methods? 6. Okay, you're starting to get tired of me. Okay, so naggy, very hard. Okay, 6 power 3. Easy? Can our answer is just 216. This one answer should be 120. Simple? Simple, okay. You already can understand, right? Can understand, right? Okay. So actually, right, how do we get it? It's very interesting. So actually, right, there's a method to it. Let's say if there are two identical, right? Yeah, catch my breath. 3 factorial, correct? But there are two identical. Two of them are identical. All we need to do is we need to divide by 2 factorial. Okay? Can, is it okay? Is it okay? Can, right? In general, right? Okay, so number of ways to arrange n objects. In our case, example is 3. Of which 2 objects are identical to each other, then it's just n factorial over n factorial. Okay, in our case, you can see this is just 3. Okay? However, let's say there are n, okay, so my confusing. Okay, so let's say there are n objects, there are r different groups. So there are many groups of identical objects. Many groups. Mine just a small example. There are many groups of identical objects. Then, suppose there are two identical, one group of 2 blue markers, one group of 3 green markers, one group of 5 yellow markers. Then what will happen is, how do I commute them? This will become 7 factorial, divide by 2 factorial, divide by 3 factorial, divide by 5 factorial. Okay? All the identical objects need to be put together to do factorial. Okay ma? This part. It is in your comprehensive notes, so I just repeat. Okay, can okay, meaning whatever identity, 2 they are the same, 2 factorial. Another group, 3 are the same, 3 factorial. Another group, 5 are the same, 5 factorial. Okay? Need me to demonstrate? Yes or no? Okay. How many codes? How many codes? 9, right? Okay, these 4 the same, right? These 2 the same, right? These 3 the same, right? Okay. So what's the number of computation? 9 factorial over 4, 3, 2. Okay? Can okay, yeah. So we are essentially dividing away the order created by the identical objects had they be considered to be distinct. So it's actually what we are doing. We are dividing the number of outcomes where if they are so-called different. Okay, okay, with that, question 9, you can see that here, okay, you will see a lot of this kind of cute letter question. Now it's statistics. All the letters for some repeat, right? So you can see number of S, right? How many? 3. Okay. Number of T, how many? 3 also, right? I, how many? 2. A, how many? 1. C, how many? 1. Okay, so you can see the number repeated 3, 3, 2. Total 10 letters, right? So 10 factorial divided by 3, 3, 2. 3 factorial, 3 factorial, 2 factorial. Okay? Can, okay. Okay, question 10. Okay, quick one. Just take 3 minutes to do question 10.